Students, this session I am going to discuss about the combustion reaction example. You know general equation for combustion reaction CxHy plus x plus y by 4 O2 gives rise to x moles of CO2 plus y by 2 moles of H2O. This is the equation. So we have discussed about this. Now based on this, they given one question. Assuming that petrol is octane, it has octane and it has a density 0.8 gram per mole. Octane formula they provide. So in exam generally hydrocarbons formula they will not provide, but in exam you have to remember, you have to apply alkanes general formula CnH2n plus 2. N is equal to 8, C8, H18. So here luckily they provide the formula, so you can continue. So here you can compare with this general formula. So in place of x you have 8, in place of y you have 18. Now you can write C8, H18 plus x means 8 and y by 4, 18 by 4 O2 gives rise to 8 moles of CO2 and 18 by 2, 9 moles of water. Now you can cancel these two. So finally what happens here? Here you will get 25 by 2 moles of oxygen. So the final equation is C8H18 octane react with 25 by 2 moles of oxygen gives rise to 8 moles of CO2 and 9 moles of water molecule. This point you can remember. Okay students. Now coming to the question. They given indirectly one clue. It has a density 0.8 gram per mole. Now you can see one part. What is the meaning of density? Density is equal to mass by volume. So that is equal to 0.8 gram per mole. That means 1 mole, 0.8 gram per milliliter. That means 1 ml gram contains 0.8 grams. 1 ml contains 0.8 grams. This point you can remember. Now, given 1.425 liters. How many liters given? 1.425 liters. Now you can convert 1.425 liters into milliliters. 1.425 liters is equal to 1.425 into 10 to the power of 3 milliliters, that is equal to 1425 milliliters. Okay. Now you can continue the process. 1 ml is equal to 0.8 grams of octane is there. Then 1425 ml contains how much? That is equal to 0.8 into 1425. That is equal to what? If you multiply these two, you will get approximately 1140. Okay? Right. Now, 1140 grams present. This is the thing. Now, molecular weight. Molecular weight how much? Molecular weight of octane how much? C8H18 is equal to 8 into 12 plus 18 into 1, that is equal to 96 plus 18, that is equal to 114. What is the molecular weight of the octane? 114. Now you can calculate the number of moles of octane. Number of moles is equal to given weight by gram molecular weight. Given weight how much? 1140 grams. And molecular weight of octane how much? 114 grams. You can cancel these two. Finally, what is your answer? That is equal to 10 moles. Now you have calculated the octane moles. Understood students? Petrol has octane and it has density. From the density, from the volume, you are calculating the number of moles. Now you can take the main equation. So this is the main equation. C8 plus 25 by 2 O2 gives rise to 8 moles of CO2 plus 9 moles of water. This is your equation. Now you can take from the equation, they are asking complete combustion will consume how many moles of oxygen. Now you can take 1 mole of octane. This is 1 mole of octane. 1 mole of octane need how many moles of oxygen? 25/2 moles of O2. Okay. Then 10 moles of octane, how much? That is equal to 25/2 into 10. That is equal to 125 moles of oxygen. Okay, students. So this is the concept. So simply what we have done? First what we have done? We have written the balanced chemical equation. This is the first point. After that, we are calculating the number of moles. From that number of moles, I have calculated the number of moles of oxygen consumed. Number of moles of octane calculated, and then I have calculated the number of moles of oxygen consumed. This is the concept related to combustion reaction. This is the process to solve this question. Okay, students?